My friends, welcome back to another exercise, my 200 3D CAD models series. In exercise 77, I can do this in 3 sketches. So I'll be using part workbench. Let's go ahead and start calibrating our sketch. This 116. Make that half transparent. That should do for now. So I will be starting with this base. So this in the front. Let's put that on XC. All right. And here's the axis cross. So let's go ahead and transform our object. I want to place this axis cross at one of the corners. That way we can start from there. Let's take the axis cross away and start sketching. So if you're first time watching this video in this series, this is a 200 3D model building series in FreeCAD. I'm following from a book authored by Sachidananda Jha. And so that book has about 200 different problems that I'm trying to build them in FreeCAD, and I am just following that book. So here is the book, AutoCAD Mechanical 400 Practice Drawing, and first 200 are the 2D sketching. I'm skipping those and working on the last 200 of 3D problems. So providing some dimensions, this is 25 and this is 20. Let's make these two equal. I see this is crooked just a little bit, it will be vertical. Now obviously these two will be equal. We don't have to specify that one. This length is 116. This length is 76. Okay, so it's given there. All right, we got our first sketch base. I want to extrude that for 30 in a symmetric fashion. So that way that base is standing on both sides. The next, we want to work on this spline, and I see there are a lot of decimals in the dimensions, so I will have to be careful about it. Tell you what, I probably want to work on this donut first. I'm gonna go ahead and then draw another sketch. Let's go ahead and work on this donut first. So it will be an XZ plane, right? And the center is 120 millimeter away from the top of the base. So should have placed this origin right here, but it's okay. There will be one circle, and then there will be another circle, and this center is, it will be 120 plus 25 millimeter away above the axis cross, and from this axis should be 106 millimeter right side. We got these two taken care of, right? This inside diameter is 20, so 50 diameter, 25 radius, and the outside radius is 50. We got that donut taken care of. It will be sketch donut. Well, if it was, I was working on part design workbench, I would have to work on sequential order. I'll have to work on this piece and then the next piece, so they are connected, and then the donut. In part, I, I have that flexibility that I can jump onto the next part, and that makes easy for me. Not that it matters too much, but the flexibility is there. I want to extrude that, so that extrusion will be, it's 40. Now let's do some calculations. The mid is at 5, so 35 towards me, 5 behind me. So 35 towards me, 5 behind. That is our donut. Right? Looks a bit awkward, but hopefully that will work. The next thing I'll have to work on this spline thing, which I'm a little bit intimidated to start with, but let's go ahead and then take care of that. On this one, so there is one radius 149.1 and one is 45. I'm thinking this is a derivative radius. This is actually what the author went with. So we'll go with this one. So first thing first, take a polyline and maybe take this line as our reference and turn on the section view. Well, I want to pull in as our reference as well. All right. So this radius will be working. We'll think about it later. We'll just build it. So there is a straight line, right? And then there is a arc touching this circle. And let's see, I'm just gonna start with connect this line, right? And there is another straight line. There is another arc touching circle, right? And let's go ahead and then connect these two. Okay, so these two lines will be tangential, so will be these two. And then apparently this is 33.3, this is 33.3, so these two are equal. I want to place this 96 diameter there real quick and say this two distance, the point is 10. That's 10 millimeter away from the edge. Right, we got that. Now this radius is 45, so let's go ahead and place that, and that constrains everything. Like I said, I didn't have to specify this radius or this 33.3. These are extra dimensions. I didn't have to just go with those. I went with my intuition to take the round figures only. That worked out pretty cool. Okay, so this is sketch line. I want to extrude that for 10 in symmetric fashion, so that way it's matching there. Okay, now take these two parts and connect it with our connect object. So this tool, what it does is it takes the best of it and then connect it. So before that there was a half circle, so there is this half circle thing. It to me this tool looks like most like an AI tool, which is not, but that's what I would say it feels like. All right, now what I want to do is I want to make these two a union, and finally let's take a look at this. That's the only fillet. I want to take all these 4 lines and make an additive fillet from here. I'm gonna go with 1 millimeter for now. Too small. Go with 2 millimeters. Let's see what the technical drawing call for. Oh, it's calling for 3 millimeter actually. So yeah, why not? Yeah, that's our object. It's a little asymmetric, not symmetric. Okay, so there is one thing. These lines, they look bad, and we normally use the refine tool to take them away, and fillet takes that refining option away from us. So let's go ahead and then refine it first, right? Make it look good, then apply the fillet. So if we have to do refining and filleting, refining should be done first. Here, that is our object. It's a little asymmetric, and loading pattern is really interesting. Tell you what, let's do an FEM analysis on this to see how this object bends. I'm thinking this will be a pedestal, and then there will be a cylindrical rod goes through here. And so let's do that. So we got the final object, and I want to start FEM workbench. So begin with container and a solver and a material, and I want to go with aluminum. Right. Then it will obviously be fixed at the bottom. So let's go ahead and add these two faces as our support. Right. After that, I want to apply some load. I cannot apply pressure because it's a circular surface. I want to apply some load here. So direction looks bad. I'll go ahead and select direction downward. Okay. And then I want to say 100 Newton. We applied the load. Now I'm going to go ahead and then apply some end mesh. It was easy. Now let's go ahead. So we have the solver and the material and support system, loading system, and the mesh. Now we are ready to do the FEM analysis. It says calculate execute error. Don't know why. Let's go ahead and then work with the mesh thing. Probably that fillet thing. Okay. On the fusion, I just removed the fillet. Let's see if it makes easier. Final object and start over. There is an analysis and a solver. The material. I'll go with aluminum. Then I want to apply these two surface. My support, like fixed support, right? And now I want to apply some load. So there will be load. Let's take this direction, take care of it right now, and add the face. say 100, say 1000. All right, now time to do some mesh. Let's see if this works now. So run calculus. Nope, it did not work. How about Gmesh? It was not the filleting, something else. But although there was some error in the Gmesh, looks like we got our results in. Good. Okay, let me hide this, hide that one, and let's see the bending profile. That's all we wanted to see. Okay. Displacement magnitude. There will be 0.33 millimeter displacement. I want to see how it bends. Okay, that's interesting. I thought there will be some twisting. So now there are some twists. Okay. If you can see, look at here. So as you can see, it's twisting just a little bit, but it's bending the symmetric side. And the maximum stress is coming somewhere here. Okay. Yes, there. It's bending, so there are some negative stress on this edge, and most stress is coming around here. Anyway, that was fun. I thought it would be twisting a little bit more, but it's not twisting that much, just a little bit. But as you can see, we all knew that because it's asymmetric, the bending would be on this side. We can see that. FEM also thinks so, but there will be some twisting as well. Anyway, hopefully you liked this video with the demonstration on FEM on how this object will be bending under load. I will see you in the next video. Thank you for watching.